Mr. Yenegu Nikhil, a PhD student from the Department of Chemical Science, IISER, Kolkata. He will be presenting on on the topic Journey of Heisenberg Uncertainty Principle, the known, the knowable, and the unknowable.
Thank you very much. So today I will be presenting on journey of Heisenberg uncertainty principle. So before going further, I would like to dedicate this small presentation to who inspired me in this field, Dr. T.D. Singh and Sri Varun Agarwal sir. So I will start with very simple thing. One is concept of position. So how it has evolved over the time. So in prehistoric times, people used to tell, "I am near cave, I am near river." Nowadays we also use, "I am near shopping mall, I am near hospital" or something. And but when in medieval times, what happened? This position, they in as geometry developed and the people have interested got interest in astronomy, they have defined 2 points and the distance between them they have calculated. One they took as reference point, another they took as uh, told the distance, just like planets distance between earth and moon, earth and sun, so like that. And in Newtonian times, the coordinate geometry has developed and he has defined with respect to Cartesian coordinates, and we got the position got represented in form of vector. And in that, the Newtonian assumes it's absolute and measurable, and point is a fixed in unchanging coordinate system independent of observer. So whereas as as science progressed, we have shifted from classical mechanics to quantum mechanics, where the position and momentum, they were independent and they were commuting. But Heisenberg, when he is trying to explain hydrogen atom spectra, we he found that these two operators, means the position and momentum, they were not commuting. And from here, we have transferred from vector to representation of matrices. And as there are, as quantum in early stage quantum has started, so there are two classes I have developed. One is school of matrix mechanics, another school of wave mechanics. But sorry, so but in wave mechanics, yes, Eisenberg, Schrodinger has shown it is equivalent to matrix mechanics, but in they were trying to find the meaning of wave function. So in trying to meaning of wave function, Pauli actually was also contemplating on this question. When uh, when two masses collide in classical mechanics, we can know their final position and final momentum by using conservation of loss, conservation of energy, and conservation of momentum. But whereas if you assume two electrons are going on, then he faced a problem, and he faced a problem and wrote a letter to Eisenberg as well to include on how to interpret the probability of wave function. So there, Eisenberg, in an attempt to answer that question. So previously, before Eisenberg, we already know charge by mass ratio of electron experiment. So here you see this is nothing but stream of electrons in a chamber where water vapor is there. And so here in this, if the electrons are moving, the whatever we are visibling, we are seeing, if it's electrons, then we know the trajectory of electrons. But where but it is because of it is because of the condensation of water vapor that we are seeing. Actually, this is uh, means the water molecules got ionized, and that we are seeing in back calculation. So Heisenberg got to conclusion it can be known only approximately, the position and momentum can be known approximately only. And this further led to ask him a question: can quantum mechanics represents a fact that electron finds itself approximately in a place or with a given velocity? So he already know the commutation relation. From there, in his exercise, he has derived Heisenberg uncertainty is principle uh, determining the accuracies with which, and to his surprise he found there is a limit where we can exactly know the trajectory. So to explain this, he has taught an experiment where, see, this is electron, and to observe anything, light has to incident upon that. So gamma ray has been assumed. So but to measure the position of electron, it scatters, and be, because of this you cannot really know exactly position and momentum with absolute accuracy. So this has further led to him asking that plenty plenitude of possibilities are there, because when in this diagram, when photon hits, electron can go in any direction depending upon the energy of the photon. So there he is thinking how my measurement interaction creating a range of possible outputs, which he described it as superposition of measurement eigenstates. So from there I come to conclusion electron can be anywhere, but from all these possibilities we can come to only one actual outcome. So this transition from many measurement possibilities to one measurement actuality, he termed it as collapse of wave function. And in his Bohr, actually Heisenberg was a student of Niels Bohr. So in Bohr's model, he was trying to interpret, okay, if I send photon, if the photon hits the electron, it can, I want to know how fast it is moving and which orbit it is moving. So, but if the photon is I in energy, it can actually excite the electron, and we even lose the meaning of defining path or orbit. So this has led, actually, there was an interesting story. Niels Bohr went for a vacation, and Heisenberg actually he derived the uncertainty principle, and then as soon as Niels Bohr came, there were many questions he was asking. There were many dialogues further, and how to really interpret this result. So Heisenberg was asking, we cannot talk about properties of particle as if they existed independently of observation. Independently of our observation means independent of measurement. Bohr is asking, its nature is exposed to our question of methoding. Heisenberg further continues, so observer becomes part of the observed. It means the measuring apparatus is not neutral, it defines what can be said about the nature. So there were many means not only Heisenberg and Niels Bohr, there were many other great minds have joined in the conversation, and they were debating so many things. Primary things are observer effect, complementarity, and limits of language. So from all these things, they it is scope of beyond the scope of presentation to present everything, but main thing is they have gone from deterministic description to probabilistic expectations, and they have also gone from non-objectivity of quantum states before measurement. So even after many years we can even experimentally verify these limits. There are many experiments. So now I will go to some what are Eisenberg thoughts over is this concept of position and momentum. So Eisenberg is telling the words position and momentum of an electron, for instance, seem perfectly well defined as to both their meaning and their possible connections. In fact, were clearly defined concepts within mathematical framework of Newton mechanics. But actually, they are not well defined as seen from the relations of uncertainty. So this point I will explain in next slide, in next two slides. So this he tells one may see this regarding their position in Newton mechanics. They were well defined, but in the relation to the nature, they were not. This shows that we can never know beforehand which limitations will be put on the applicability of certain concepts. By extension of our knowledge into remote parts of nature, into which we can only penetrate with most elaborate tools. Therefore, in the process of penetration, means transferring concept from one domain to another domain is telling we are bound sometimes to use our concepts in a way which is not justified and which carries no meaning. So this insight he has given, this one I will I will summarize that in 2 points. He is telling that measurements gives meaning to the definition of concepts and the limitation of such definitions when considered simultaneously. So this simultaneously point I will explain. Measurement creates actually the physical reality of observable. So in this book, he was trying to derive the interpret the measurement. So there he has derived measurement is meaning. Measurement gives meaning. Measurement actually creates the creation of uh, means the observable. So why he has this opinion is because definition for one quantity are subjected to particular indeterminates obeying the uncertainty relation, which prohibit from providing a simultaneous definition of two canonical conjugate quantities. So in here, in his example, if for example, position and momentum, you cannot simultaneously define both of them at one particular, but you can define later on. And this he now speaks of a limit of definition of concepts that is not merely on what we can know, but what can be meaningfully said about the particle. And it tells that he claims that no experiments that allow a simultaneous precise measurement of two conjugate quantities, so they are simultaneously not well defined. That is the limitation of our concepts. Simultaneously we cannot define. So the concept of position from Newton to Heisenberg, it became uncertain and probabilistic. And according to quantum mechanics view, particles do not obey a definite position until measured, and position is represented as a probability distribution. So this has means the concept of position, you see, it has started from a point in geometry. Then we define it as a vector, as coordinate geometry developed. And from there, we go on to matrix. And from there, when we try to give physical interpretation, we got to know there is no simultaneously, we cannot define both the quantities. Means their conjugate variable. And concept of position beyond quantum mechanics, you can even have in relativity. Position is relative to the observer's frame of reference, and space time is intervened. So this is also another dimension of thinking, means another dimension of development. Previously space time was not intervened before relativity, they were considered absolute. But this gives the position, the distance. If you see related books, distance, it has relation with velocity as well, means from which frame of reference you are observing. And beyond that, even quantum field theory, where everything is described in terms of field. So the particles actually described as expected excitations of fields. So there you cannot even define the position of a particle, becomes much more subtler and often not sharply defined. So this is about the concept of position. Now we will go to Heisenberg, who what happened beyond when he was evolving through these concepts. So there, in his later years, you can see is these two books. He has described his experiences and over the journey. So here he gone from reality, observe, trying to explain hydrogen atom spectra, little by little developments. He came to reality, and from there he came to possibilities, and from their mind consciousness, he has described world, I, and God. So this one I will elaborate in next slide. So here you see, in this book Physics and Philosophy, he has described very elaborately uncertainty principle. It has two aspects. One is uncertainty, and another is interconnectedness of the two conjugate variables. Okay, interconnectedness of two possibilities. So uncertainty, he has attributed it, there is possibility which it exhibits mind like character, whereas interconnectedness between the conjugate variables, which later got to know it can be beyond space and time as well. So that has conscious like character. So more details if you want, you can read the physics and philosophy book. And this okay, this one I will read the entire quote, where is telling the I will concepts concepts of natural language in the process of scientific development. One sees that after the experience of modern physics, our attitude towards concepts like mind or human soul or life or God will be different. Why is telling? Because concepts are not well defined in the scientific sense, and their application may lead to various contradictions. For the time being, we may not have the concepts unanalyzed as they are, but still we know that they touch reality. So he's giving example also how to define how we should include mind and soul. Yes, draw analogy. Just like in mathematics, we have introduced concepts of imaginary numbers and infinity. So, but still, we don't really understand the general rules. We understand partly, but not generally. By complex number and infinity, it touches our comprehension beyond our comprehension level. But still, we include them in our mathematical framework. Like that, we can have efforts in this direction for mind and soul also to be included. So for that, it is very interesting to know is sun Martin Heisenberg. So he's also retired, but he's still alive. So he's neurobiologist in. So he conducted experiments on bacteria and Drosophila, and he has shown that there is free will, means the soul attributes. It is practical in reality. So he has shown some experiments. You can refer this paper maybe. Reaction independent of external stimuli, so that gives a channel to view free will. With that, following Varun sir inspiration, I would like to also tell that it is from Varun sir only I adopted. So position, you can actually, one is physical, number, matrix, point, and another is psychology. Psychology, we know, when we dream, we see many events. So events actually happen, attribute space and time, right? So and another is spiritual also. We'll tell someone you have a special place in my heart. So what does that inner meaning when you want to keep in mathematical framework? So to justify my title, I will come here. So incompleteness of modern concepts. So that is one attribute Heisenberg has highlighted, and he has hinted at issue of free will and some nature of mind as well. So to justify my title, so known we can go to mathematics. Unknowable we can attribute it to measurements. Unknowable it is meaning and art problem of free will. So this is more or less my last slide. So complete journeys. So this is very important. So we know from there are two aspects. So one is science, another one is the scientist who involved. So science we know we study applications. So there have been developed many technologies based upon Heisenberg understanding of Heisenberg uncertainty principle. And another one is foundations where limitations in concept. This if you think more on the limitations of concept, what it gives clues for reality beyond physical reality. So it touches beyond physical reality. This is one aspect. So another one is scientist. So this we miss, but luckily, fortunately, with my association with the Bhaktivedanta Institute, I can at least tell. So scientist, he has two things. One is he himself, when he undergoes the journey, he revolution in his personal value beyond physical reality. Even if you see Schrodinger as well, Schrodinger also has the same experience. Another is influence on others to explore reality beyond physical existence. So this one I have shown you. Eisenberg has actually inspired in a way his son to explore free will in very biological setup. So with this, I would like to acknowledge my professors who has taught me at least to comprehend the mathematical physics, to understand the quantum mechanics. Another is my mentors, Varun Agarwal sir and Vasudev sir. So to read founder's book. So with their inspiration, I read the books. And another one is my friends who has actually took me this to conference. When I was in fourth semester. So they took me to this conference. So from there I got little bit inspiration from there. And another one, I would also like to acknowledge Azure Kolkata, DST Inspire, and my parents for supporting my education. And these are my references. Thank you.
So we have a question for Mr. Nikhil. The question is, what is correct meaning of meaning? I think measurement itself actually distort the meaning rather than giving any meaning.
So there are two aspects for this. So you have to think when you are in which domain you are probing the reality. So first is you have to the probing reality has to be much greater in scale, means length scale or time scale. It has to be much greater than through your measurement. Am I correct? I think, I hope I remember that. So if if the two domains are of various as gap, then you can give meaning of meaning. But when the probing things and the thing with which you measure both are of same scales in space, means distance and time, then this becomes a little bit difficult. So but okay, I think I will. It's very difficult for me to answer. Maybe it is little bit paradoxical, but it is falls in domain of knowable and unknowable. In this spectra, it has. So depending on asking the question, we can think maybe what meaning you are asking. So for example, wave function meaning, we know we know one aspect. What is the meaning? So people have tried and they have come. It is a wave function probability. But if the wave function, if you ask the abstractness of the mathematics, and if you define the state of the system is in superposition, then you lose the meaning, because means lose the meaning means it is beyond our accessible limit. So with this example, I would like to conclude this question. If the person is interested, you can actually read literature on the development of meaning of wave function. It has almost 3 years journey for the scientists to really. It is 1 year journey, but the debates goes on for 3 years. You can read the conversations between great minds.
The next question from the audience is, the metaphysical dimension of positioning is something not so straightforward to comprehend. Could you be specific more on this? Are you still exploring?
Yeah. So this is little bit tricky, because this question is little bit tricky because from our education from our method of development of science, we are always got into framework of thinking everything in mathematical framework. But if you see even in Newton's book or just early also, this channel exploring the reality through mathematics. But can't there be reality beyond mathematics? So this is the question we should think. It has already been taught. Not this question has been put by many philosophers. So can't there be reality beyond mathematics? So this is the answer for this is reverse question for your question. Means so people have thought there can be reality beyond mathematics also. So when you want to define position beyond metaphysical level, we have to find a framework which is semi mathematical. Means it can be mathematical but it can be beyond mathematical also, because in psychology, if you see the field of psychology, you can actually what to tell, you can define attributes. You can actually them a questionnaire and they can know the things. You can attribute a number but there is also non there are aspects which you cannot assign a number also. So with that, I would like to uh, actually here people has to think how to actually develop. Is there any other framework, bigger framework than mathematical framework? Thank you.
I would like to make a comment. In the first version of the uncertainty paper written by Heisenberg was incorrect
Yeah.
because, as you mentioned here, he thought that the recoil due to the collision with the photon is an uncertainty. But Bohr pointed out that that's not correct, because if you can measure the recoil precisely, then there is no uncertainty, even though the electron may have got disturbed. And what Bohr did in 1927 in the Como lecture was to do this much more carefully and show where the origin of uncertainty is. And in fact, Heisenberg accepted that and modified his first paper. So that recoil is not the uncertainty.
Oh, okay. Yeah.
Thank
I will I will read that.
Okay. I just want to make one comment, not to you, but to the questioner, to the person who posed the question, the meaning of the word meaning. I personally think the best answer could have been provided by Bertrand Russell, and no other than by Bertrand Russell. This is my personal opinion.
Yeah, my question is on free will. So heard of your argument. So there are two arguments on free will I would like to briefly mention. One says that by David Eagleman, the neuroscientist, he said that since every part of the brain is really interconnected, and for me to take any action, physical action, the brain might like neural signals might come to through the motor neurons to my muscle and everything. So it's all interconnected. So there is no space for any free will. Of course, it appears free, and free will is a very important pragmatic concept in society. Without free will is
Yeah.
unimaginable. But scientifically, he claims that free will does not exist. And there is one another argument which is you didn't mention, but I would still like to mention. It's that quantum. Many people say that the uncertainty or randomness in quantum physics leaves some room for free will. Well, actually, that's not true, because even if quantum outcomes are random, I cannot influence those outcomes to exercise my free will. So, what is your opinion on like what do you personally think is does free will exist or not, taking everything into account? Like,
Okay. So you have two questions. Means first question, actually uncertainty really doesn't it about free will, but the thing is, Eisenberg was thinking why nature has a fundamental limit beyond which we cannot probe the observables. So depending upon thinking on this question, he thought many days, and then he came to conclusion we cannot means there is the universe has been designed that we cannot probe beyond certain limit, that access is not given to uh, the individual living beings. So why this is there? So from there the free will debate starts, but it beyond that limit, beyond Planck's limit, that is free will exist, but before that you can interpret the reality without free will. And the Martin Eisenberg paper, if you see the title, is free will an illusion, the question mark, the title of the paper is that. Maybe you can read that paper. It demonstrates something, though it is still open field. People really don't have any concrete framework to interpret free will, but everyone has their own opinions. You can also have your own opinions.
thank you.
Thank you, Mr. Nikhil.